today's goal of this lecture. Today I will see ring theory just as a review. I will see different type of question about ring theory just as a review. This part just as a review part. First, I will see some question about principal ideal. We all of us know principal ideal is those ideal which is generated by single element. At first, recall the definition of principal ideal. An ideal which is generated by one single element is called principal ideal. And every ideal of Zm is always principal ideal because every ideal of Zm is Mz type. This is always generated by single element, so this is as a principal ideal. And every ideal of Z is also principal ideal. Then, when F is a field, then F has exactly two principal ideal. Because we all of us know F has exactly, when F is a field, F has exactly two ideal, one zero ideal, and when field is generated by unity. Because when the field is generated by unity 1, this is actually this is generated by unity, then it is actually equal to whole field, which are these are generated by single element. Hence every ideal of field is principal ideal. Okay? That means every field have exactly two ideals, zero ideal and field generated by 1, which are principal ideal. Zi, ideal generated by A plus IV, this is always isomorphic to Zp. If GCD of AB equal to 1 and A square plus B square equal to P, where P is a prime number, then this is always isomorphic to Zp. That means Zi modulo ideal generated by A plus Bi is isomorphic to Zp, and Zp is a field. So it has, since this is the field, so it has exactly true principal ideal. Okay? OL. I equal to ideal generated by 2x is not principal ideal of Zx, because here the ideal generated by two different element, ideal I generated by two different element and x. Now consider the ring Rxy or Cxy or ZPXY or zi xy or zxy, then I equal to ideal generated by xy is not principal ideal of this ring Rxy or Cxy or Zpxy or Zixy or Zixy, because these ideal here generated by two element, generated by I is generated by two element x and y of the ring R. Consider this is equal to R. Okay. Or if I equal to ideal generated by 2x is principal ideal of qx or not. Ideal generated by 2x means actually this is look like 2 times fx plus x times gx, where fx gx belongs to qx. Okay. If we consider fx equal to half and gx equal to 0, half belongs to qx, also gx belongs to qx, then 2 times f of x plus x times g of x this is equal to 2 times half plus x times 0, this value is equal to 1, and 1 belongs to the ideal I, and this is equal to 2 comma x. Since if 1 belongs to ideal, then ideal I equal to generated by 1, which is equal to ideal generated by 2 comma x. This is nothing but, since this ideal is contain unity, so this ideal is actually whole ring qx, and since if q is a field, then qx always principal ideal, so this ideal is principal ideal of qx, but this ideal is not principal ideal of zx. I hope my all viewers have understood. So ideal generated by m comma x is this ideal is principal ideal of qx, where m not equal to 0. I hope my all viewers have understood principal ideal. Today I am discussing principal ideal just as a review. An integral ideal is said to be P.I.D. if every ideal in this integral ideal is principal ideal. That means in integral ideal, if every ideal is generated by single element, then this integral ideal is called principal ideal domain. Okay. Now I will say some rules of irreducibility just as a review. Just as a review, I will say some rules of irreducibility. Today I will say cyclotomic polynomial. We all of us know cyclotomic polynomial always be irreducible. Today I will see some result on this cyclotomic polynomial. Now I will say some irreducible test, today I will see cyclotomic polynomial. We all of us know cyclotomic polynomial is look like this type 1 plus x square up to x to the power p minus 1, and this polynomial for any prime p, this polynomial always irreducible over q. If given f of x equal to 1 minus x plus x square minus x cube up to x to the power p minus 1, then f of minus x equal to 1 plus x square plus x cube up to x to the power p minus 1. This polynomial reduces cyclotomic polynomial f of minus 1 times x, and this polynomial so for any prime p, f of x is irreducible over q, since this polynomial would be reduces by this polynomial. Okay. Next, f of x equal to, consider minus 1 minus x square minus x cube up to minus x to the power p minus 1, where p is a prime number. Then minus 1 times f of x equal to this polynomial, when minus 1 times f of x would be 1 plus x square plus x cube up to x to the power p minus 1, where p is prime number. Since minus 1 times f of x is actually the cyclotomic polynomial, so when p is a prime number, so this is also irreducible over the field q. Okay. As for example, f of x equal to minus 1 minus x cube minus x to the power 4. For the prime p equal to 5, f of x is irreducible over the field q. If x equal to x to the power 4 plus x square plus 1 over z, we can write this as x square plus x plus 1 x square minus x plus 1. Since we can write this as product of two irreducible polynomial, because notice if you factor this term, this would be x to the power 4 minus x cube plus x square plus x cube minus x square plus 1 plus x square minus x plus 1. Here x to the power q would be cancelled, x square would be cancelled. Here would be plus x, so this would be cancelled. So this is equal to x to the power 4 plus x square plus 1. So x to the power 4 plus x square plus 1, we can write this as product of two irreducible polynomial x square x plus 1 times x square minus x plus 1. So since we can write fx as product of two irreducible polynomials, so fx is not irreducible over fx is not irreducible over z. Fx equal to, if x to the power 4 plus x plus 1, this is reducible over z2, because we can write this as x square plus x plus 1 times x square minus x plus 1, and over Z2 we can write this as x square plus x plus 1 times x square plus x plus 1 over Z2. Fx, we can write this as product of two irreducible polynomial. So over Z2 this function fx is reducible. If you factor this polynomial similar to before, these two factors, then you will get actually fx. So over Z2 this polynomial is reducible over Z2. Next, fx equal to x to the power 4 plus 1. This is belongs to Z3x, and here degree of fx equal to 4, which is greater than 3. So we cannot apply here root test, because here we can apply root test when fx is degree 2 or 3. Root test is if there exists a such that f of a equal to 0, then we can tell the function is reducible. Since here degree is greater than 3, so here we cannot apply mod p irreducibility test. But over Z3 we can write fx as product of two irreducible polynomials such as x square plus x plus 2 times x square minus x plus 2, because if we factor it, that this would be x to the power 4 minus x cube plus 2x square plus x cube minus x square plus 2x plus 2x square minus 2x plus 4. This would be cancelled. Then this would be x to the power 4 plus 3x square plus 4, and over Z3 this is becomes x to the power 4 plus 1. So we can write product of two irreducible polynomial fx equal to x to the power 4 plus 1 over Z3. So this polynomial is reducible polynomial over Z3. Okay, I hope my all viewers have understood this type of question. Okay, well. Now px equal to x to the power 4 plus 3x square plus 2 belongs to qx. Then qx modulo ideal generated by px, this is equal to the set fx plus ideal generated by px, where fx belongs to qx. Then px equal to x to the power 4 plus 3x square plus 2, we can write this as x to the power 4 plus 2x square plus x square plus 2, which is equal to x square. This would be, we can write x square, then this would be x square plus 2 plus 1 x square plus 2. This is equal to x square plus 1 times x square plus 2. Therefore, since px, we can write px as product of two irreducible factor, so this is reducible over q. And we all of us know in P.I.D, since qx modulo px is isomorphic to field when px is irreducible polynomial. Since px is reducible polynomial over q, so qx modulo px ideal generated by px is isomorphic, does not isomorphic to field. Okay, so obviously this polynomial is not maximal ideal of qx. I hope my all viewers have understood. Okay, well, and not only this is field, this is also not integral domain, because in PID maximal ideal and prime ideal, this is if and only condition. Since this is not irreducible polynomial, so this is also not prime ideal in QX. Not prime ideal, and when this is not prime ideal, so when this is prime ideal, then this would be isomorphic to integral domain. But since this is not be a prime ideal, so this is not also isomorphic to integral domain. Again, by definition of prime ideal, notice here x square plus 1 times x square plus 2 belongs to the ideal generated by x to the power 4 plus 3x square plus 2. Okay? But neither x square plus 1 belongs to ideal generated by x square plus x to the power 4 plus 3x square plus 2, nor x square plus 2 belongs to ideal generated by x to the power 4 plus 3x square plus 2. So, this is ideal generated by x to the power 4 plus 3x square plus 2. This is not prime ideal in QX. And since this is not prime ideal, so QX modulo ideal generated by PX is not isomorphic to integral domain. This is by definition. And a shortcut trick is, in PID, maximal ideal and prime ideal is if and only if condition. When in PID the polynomial is irreducible polynomial over the ring, then we can tell this is isomorphic to field. Okay? I hope my all viewers have understood this is. So this is not be also integral domain. Next, if R equal to QX modulo ideal generated by x to the power 5 minus 1, we can write this as QX divided by ideal generated by x minus 1 times x to the power 4 plus x cube plus x square plus x plus 1. We can write two reducible polynomial. And QX modulo ideal generated by ij is isomorphic to QX. If this is I and this is j, then this is isomorphic to QX modulo ideal generated by x minus 1 cross QX modulo ideal generated by x to the power 4 plus x cube plus x square plus x plus 1. And this is isomorphic to Q, and obviously QX modulo ideal generated by x to the power 4 plus x cube plus x square plus x plus 1, this would be any field. This would be isomorphic to any field. So this would be Q cross A. Here Q is a field and this is also field, but Q cross A, this is not integral domain. Where F is a field. Then Qx modulo x to the power 5 minus 1. This is isomorphic to Q cross F, which is not integral domain. So this is not field also. Okay. I hope my all viewers have understood. Okay. Well, today I will stop here. In my next video, I will discuss some more question about this topic briefly, because this type of question actually very important for any competitive exam. Okay. See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.